Ever heard of the term quantization in AI and wondered what it means? Well, let's demystify it. Picture this, you're trying to pack for a vacation, but your suitcase just isn't big enough for all your things. What do? You might start by downsizing, maybe folding your clothes a bit tighter, or leaving out a few non-essentials. That's essentially what quantization does for artificial intelligence models. In technical terms, it involves converting the weights and biases of an AI model from their usual floating point format, think decimals, to integers with fewer bits. But in simple terms, it's a bit like shrinking the model's memory footprint, making big models fit in small spaces. So, just as you'd pack more efficiently for your vacation, quantization helps AI models become more efficient, fitting more information into a smaller, more manageable size. In essence, quantization is the process of making big models fit in small spaces. Now that we know what quantization is, you might be wondering, why do we need it? Well, let's think about large language models, or LLMs for short. Picture these LLMs as hungry giants. They have a big appetite for memory and energy resources. But here's the catch, not every device or system can cater to these demands. This is where quantization steps in, playing the role of a fantastic dietitian. It helps shrink these memory-gobbling giants into more manageable sizes. Imagine the convenience of saving a significant amount of storage space on your phone or computer, just like when you compress a large video file into a smaller one without losing its quality. Moreover, quantization doesn't just benefit storage, it also contributes to faster processing and lesser energy consumption, making the operation of these large models more sustainable and efficient. So, quantization is the key to making large models more manageable and efficient. Ready to dive a bit deeper into how quantization works? Alright, let's get our hands dirty with the technical stuff. When we talk about quantization, we're mostly referring to two key elements, weights and activations. First, let's tackle weights. These are the model's learnable parameters. They're like the model's memory of what it has learned from training data. Next up, activations. These are the intermediate values during computation, kind of like the model's thinking process. Now, traditionally, these weights and activations are stored as 32-bit floating point numbers. That's a lot of data, right? But here's where quantization pulls a rabbit out of the hat. It says, hey, let's use 8-bit integers instead. By doing this, it significantly reduces the model's memory footprint, making it more compact and efficient. Quantization is like a magic trick, transforming 32-bit floats into 8-bit integers. Now the big question, what's in it for us? You might be surprised. Quantization brings a trio of tantalizing benefits. First, speed. With smaller data, computations become faster, zipping through tasks. Next, memory. Less space is needed, making it perfect for your pocket-sized devices. Finally, energy. Reduced power consumption means longer battery life and a happier planet. In essence, quantization not only makes models smaller, but also faster and more power efficient. Ever heard of the term knowledge distillation in relation to quantization? Well, it's a technique where a smaller model is trained to mimic the behavior of a larger one. It's like creating a mini-me of the larger model. This process is key to preserving the accuracy of the model post-quantization. So, while the model gets smaller in size, we ensure its wisdom or its learned knowledge is not lost. Knowledge distillation is like teaching a mini-me, transferring the wisdom of a big model into a smaller one.